Hi everyone, this is the first lesson on solving simultaneous equations, and this will be a video to show you how to solve two sets of equations when you have two different letters. So if we have a look at the example here, you can see we've got two equations, x plus y equals 11 and x minus 3y equals 7. So because we've got two different letters and two different equations, we have to solve this slightly differently. And we solve them simultaneously. We work them up, the two equations out together. So the reason we have two equations is because we have two unknowns. If we have three different letters, three unknowns, then we would need three equations and so on. Now, there are two methods that we could use here. One called the elimination method, and the second called the substitution method. Both are very useful for different types of simultaneous equations, and I'm going to show you both with this particular example and then talk to you about which one I would prefer depending on the equation. So if we look at the elimination method first, we are going to write out the two equations. X plus y equals 11 and x minus 3y equals 7. Now, normally I label the equations A and B, so I know which one's which, because it depends on what I'm doing, depending on the step I'm doing as well. Now, the elimination method is, as it says, you are going to eliminate something. We are actually going to eliminate one of the letters in the two equations by subtraction. Now, sometimes we do add as well, and we'll in later videos talk about when we would add and when we would subtract. So if we do a subtraction, and if I subtract these two equations from each other, okay, and if you imagine doing a subtraction, we should just subtract each of these terms as if they're an individual digit in a column subtraction. So if you imagine you had 395 subtract 132, you would just subtract each column from each other. Okay. Now the same happens when we are solving two equations. If I subtract, I would do x, take away x. They will cancel each other out because x take away x is 0. Y subtract negative 3y. Now this is where we've got to be careful because we've got two negatives. And remember, when we are subtracting a negative, it secretly means we're adding. So just keep that in mind when we do have two negatives. So what I'm really doing is y add 3y, which is 4y, equals 11, take away 7, which is 4. Okay, try and keep everything in nice neat columns, so x is together, y is together, equals together, numbers together, and it makes it a lot easier to solve the equation. Now, by doing the elimination method, this is the good thing about this method, you get rid of one of the letters that you're trying to work out. So that's what's happened here. We've got rid of all the x's, and we're just left with one variable to work out. So now we can just work out y by solving this equation as normal. So get rid of the 4 by dividing by 4 on both sides. So 4 divided by 4, which means y equals 1. Okay, now this is not where we're finished. A lot of people make this mistake. They think, right, we've worked out an equation, I'm all done. But you got to remember there are two letters in our two sets of equations, an x and a y. And you need to go back, and now we substitute to find the second letter. So here I'm going to work out x by substituting y equals 1 into equation A. Now, it actually doesn't matter which equation you use. You can choose the first or the second equation. The reason I'm choosing A is because it's all positive, and it just makes it a little bit easier to solve. Not that it's impossible to solve with negatives, it's just a bit more straightforward when everything's positive. So I'm going to write the equation out. X plus y equals 11. But because I know y equals 1, I'm going to replace this y with 1. And I can see something add 1 equals 11. So my x must be 10. And that means my final answer is x equal to 10 and y equals 1. Now, you might think, how can you know that's right? And this is the good thing about simultaneous equations. You can actually double check your answer before finalizing it. So because I only used equation A, I can now substitute into equation B, which is the second one here, or here if you're looking at the original question, to double check it actually works. So that's what I'm going to do. I'm going to do a very quick check. I'm going to check when x equals 10 and y equals 1 that I get the answer 7 in this equation. So I'm going to use B. X minus 3y equals 7. And I'm going to put 10 in, minus 3 times 1. And does that equal 7? And it does. 10 subtract 3 times 1 is 3. That equals 7. It's correct. So that means my two solutions for x and y will need to be 10 and 1, which is great. So that's the elimination method. Okay. So now we're going to look at the substitution method, and it's slightly different to the first method. So I'm just going to demonstrate here. So again, we'll look at the two equations. I've got equation A, which is x plus y equals 11, and equation B, x minus 3y equals 7. So the first step is to make one of the letters the subject in one of the equations. So we're going to make a letter the subject. And we're going to do a little bit of rearranging. Now, in equation A, 11 is the subject, and in equation B, 7 is the subject. Now, I'm actually going to use equation B to make the subject, or A, it doesn't matter. In fact, let's just use A. So I'm going to use the equation A. We're going to x plus y equals 11. So I'm going to make x the subject by getting rid of y. So I want to subtract y from both sides. X is then equal to 11 minus y. Okay. Now, that means now, once we've done this and made one of the letters the subject, this is where we now substitute. And this is why it's called the substitution method. I am now going to substitute x for 11 minus y into the second equation. Okay, so in equation B, we've got x minus 3y equals 7, and I am going to replace this x for 11 minus y, because I know x is equal to 11 minus y. They're the same thing. So by doing this, x as the subject, 11 minus y here is what x is equal to. I can replace the x in the second equation with that expression. So I'll end up with 11 minus y, and that's what the x is now become. The minus 3y is still there. We haven't replaced that, and it's still equal to 7. Now, once we've done the substitution, we're going to now simplify. And we get 11 minus 1, take away 3 is minus 4y equals 7. And now we have an equation, not with 2 letters, but just one single letter. And now that we can solve that. We can't solve equations with 2 letters unless we either do the elimination method or the substitution method, because both of these methods, what they do is they get rid of one of those letters to allow you to solve the equation. So now I'm going to solve this equation. And I'm going to do that by subtracting 11 from both sides. Excuse me. So that's minus 4y equals 4 subtract 11 minus 4. And now I'm going to divide by negative 4 on both sides. So y is now equal to positive 1. Negative 4 divided by negative 4 is 1. And you can see this is the same. So here where y equals 1, it's the same as y equals 1 on the elimination method, which is great. So now we need to work out x by substituting it back in. And we know from our rearranging that x equals 11 minus 3. Or sorry, 11 minus y. So I'm going to use that. So I know x equals 11 minus y. I know y equals 1, and I'm going to substitute that back in. So 11 minus 1, which means x equals 10. Okay. Now, again, you can check if you've done this right by substitution, just like I've done with the first method in green here. I used the equation to substitute both values to work it out to see if it made sense, and it does. So here my answers are going to be x equals 10 and y equals 1. Now, it depends on which you prefer. I'm not a massive fan of substitution method when you have 2 equations that look like this. If you have a single x and a single y, so if you don't have any x squareds, if you don't have any y squareds, if there are no indices involved, I always prefer the elimination method. If there are indices involved, so if you happen to have an x squared or a y squared or both, then I prefer the substitution method. It's actually really difficult to do the elimination method when indices are involved, which is why there are 2 methods to solving simultaneous equations. Have a try at this example, try both methods, work it through the method with the video while I'm going through it, and then have a try at the questions in your knowledge organizer. Thank you.